Okay, so one thing that, another way to kind of record things in MATLAB or keep track of things in MATLAB, so we said we have the nice command history window over here on the left, kind of a recording of all the things that we've done, but that's kind of stuck in MATLAB. And so one of the things that you're going to have to do for homework and things when you turn things in is turn in what's called a diary file in MATLAB. And so how do we make a diary file? It's really easy. So MATLAB has a command called diary, and you type into MATLAB diary, you open parentheses, and then inside the parentheses, you'll see MATLAB's kind of providing you some suggestions of what you could to put inside the parentheses. What you want to put there is the name of the file that you want to save. A lot of times on your homework, I asked you to save it as, homework 2 with your name, first and last name in there. That way, when we have all the files together, I know that they're yours and not somebody else's. But I mean, and what I'm going to do for the most times during lecture is I'll start one. That way you have a recording, you have the diary, and you have the video lecture as well. If you want to go pull that kind of stuff up, you can start them and do them in class if you want to. It's not really required, but I'll just show you guys how to do that. So inside of single quotes, you want to put the name of the file. Today I'm just going to call, we're on lecture 3, diary, and then you don't usually want to have spaces in these names. And then you have to tell MATLAB what type of file to make. These are text files, so .txt. Close your single quotes, close your parentheses, press enter, and what you should see is in your current folder window, you should now have a text file that has the name of the file that you just created. So now that's over there, and you can open that file in MATLAB. So if you double click on it, open up in MATLAB. Right now it's going to be completely blank because we haven't done anything. Or you can open those files up in like Notepad or WordPad or some other text editing software on your computer. And so we'll talk a little bit more as we get closer to your first homework, that's your first kind of MATLAB homework that's not due till next Wednesday, how I want these files when you're going to submit your homework. Because I ask you to kind of clear out mistakes and all that kind of stuff out of these files, just because that gets really tedious to search around in hundreds of lines of these files and figure out where's the answer that you actually want me to grade, or, well, not me, our helpers over there, when you want them to grade. It's always nice to be nice to the person that's grading your homework. So we'll talk about how we go about editing those when we get a little bit closer to the homework. Speaking of homework, your first homework, remember, is due on Wednesday. That doesn't involve MATLAB, so if you haven't started that, it's not too bad to do the hour of code and the little quiz about academic dishonesty. That is due at the beginning of class next time, so make sure you have that submitted on Isidore before class starts. So by 2:30, the submission will cut off, and then there will be no more submissions, and I don't accept late homework. So make sure you get it in on time, don't forget. And then bring the hard copy of the quiz to class, and we'll take those up at the beginning of class, all right? So that's how we write diary files, and then that kind of, like I said, keeps another log, another recording of what we're doing in MATLAB. So last time we talked just basics of how to save variables in MATLAB, how to create vectors, and then we talked about the colon operator right at the end of class. Who remembers what the colon operator, what the format for that is? So when we write, say we're gonna create a vector, I don't know, A. We've got 2, 4, 6, 8, 10, 12. This is the vector we want to create. If I want to do that with the colon operator, I would tell MATLAB, I'd say A is equal to, and then what do I have to put next?
The first number that you want to start.
The first number I want to start, right? So that would be 2, right?
And then you write how many you want to add to the next one.
Right. So this is what we called our increment. So that's going to be what?
2.
2. And then our last value here is just the last number, right? So 12. So if we're keeping track, we've got start, we've got increment, and we've got our finish value. So those are when you're doing the colon operator, those are the three things that you want if you want to create a vector. What if I have a vector B that's 1, 2, 3, like this? What's my colon operator going to look like?
Into digits from 1 to 3.
So we have to have the first value, right? We have to have 1. We have to have the last finished value. We have to have 3. What do we could put 1 here, right, if we wanted to, as our increment. Do we have to?
No.
No. So this is optional. So if it's 1, then this increment here ends up being optional. So we don't necessarily have to have it if our vector is incrementing by 1. Can the increment be negative?
Yeah.
Yeah, right? So we could have a negative increment too. It also doesn't have to be a whole integer number. It could be a decimal place. We could increment by -1/2. You want to be really crazy, right? So that's our rules about the colon operator. There's another trick for creating vectors, and it's called linspace in MATLAB. So the linspace function in MATLAB can help us create vectors as well. If I wanted to look up and find some information about the linspace vector or linspace command in MATLAB, where should I go to do that? Help, right? So how do I get to the help documentation? You can search, right? That's one option. What's another option for finding the help documentation?
You can write in the you can write in the code and then write help.
Right. So we could say help linspace, right? Press enter, and then we get some information about linspace. What's another option, Lauren?
You do doc linspace.
You could do doc linspace, and so if you did doc linspace, it would automatically open up the help documentation for me. What's another option besides using MATLAB? Google, right? So usually that's the easiest one to do. Then you don't have to remember documentation and all that kind of stuff. You can just Google things. So always remember that's at least 4 different ways you can find some information about stuff that's built into MATLAB. So what do we see here? So MATLAB tells us about linspace that there's a couple different options for using it. And so when we look at the help documentation, some functions only have 1 form that you can use them in. Some functions have 2, or some functions have, 10 or 15 different ways that you can use those functions in MATLAB. So you kind of have to figure out which ones are the right ones to use. And a lot of times for that, I like to go into the documentation and kind of read a little bit more about it. It'll show you up here at the top, there's 2 different ways to use linspace, one with 2 inputs and one with 3 inputs. And so how do we figure out which one's the one we want? Usually MATLAB's got an example over here to the right. So if I click on example, it takes me down to the example section, and it shows me exactly, if I want a vector of 100 evenly spaced points between -5 and 5, I can give linspace 2 things, the first value, -5, the last value, 5, and then it will automatically generate 100 points. If I don't want to do that, if I want less than 100 points or more than 100 points, so say 7 values evenly spaced between -5 and 5, I have to give it that third piece of information. I have to tell it that I want 7 points instead of 100. So that's the 2 different ways of using linspace. So by default, you get 100 points. If you want something other than 100, you have to tell MATLAB how many points that you want. Okay? So if we think about linspace kind of in the same format as we had our colon operator. So if I write this vector, this A vector, if I want to generate that with linspace, I would say A is equal to linspace, and then inside my parentheses, how many values am I going to need to provide linspace to generate this A vector? 2 or 3? 3, right? Because I've only, 6 values, so I don't want 100, so I need to tell MATLAB I want 6. So that's going to be my third one. So I have to provide linspace 3 things. So I know that the last one is going to be 6 because I have 6 numbers there, right? What are my other 2 values? 2 and 12, right? So I have my start value and I have my finish value. So very similar to the colon operator. I have to give it a start value, I have to give it a finish value, and then this is number of values, I guess we'll say. All right, so that one's linspace, just another kind of trick for generating vectors. So let's go and try that in MATLAB and see what that looks like. So if we say A is equal to linspace, open parentheses, I need to do 2, comma, 12, comma, 6, close my parentheses, press enter, and now we've got our A vector there, right? MATLAB doesn't really care if you put kind of like other things, spaces in there, so you could have 2, comma, space 12, no space, spaces in there wherever you want. It's pretty happy about however you kind of feel is the way that you want to put it into MATLAB, all right? So what if we want to create our B vector down there? What should we type into MATLAB for linspace? B is equal to what? Linspace, right? And then what's going to be our, we're going to have 2 or 3 values, so we got to give linspace for that one. 3? When are they going to be? 1, 3, and 3. 1 for our start value, 3 for our finish value, 3 for the number of values that we want to generate, right? What happens if I have a vector like this? We'll do W is equal to 30, 25, 20, 15, 10. What's my linspace command going to look like now?
Something which is basic.
Right?
And
10 is my finish value. And then I need
-5.
5. Well, would it be -5 or +5? What do we think?
No, I think
Positive 5, because we need the number of values. So in linspace, that last thing is always going to be a positive value, and it always has to be an integer, because you can have 2.5 values back from MATLAB. So it always has to be a whole number as well. So we say 30, comma 10, comma 5, and MATLAB knows that I need to go kind of in backwards order, negative, decreasing values from 30 down to 10. What about the colon operator? If I want to generate that W vector with the colon operator, what would I say? I'd say W is equal to, what's my start value going to be for the colon operator? 30. Then colon -5, colon 10, right? All right. So any questions about linspace or colon operator? Just nice, easy ways to create vectors, right? As long as they have some sort of pattern to them. What do we notice about these vectors? Are these column vectors or are these row vectors? Row vectors, right? We have all the values in one row in multiple columns. What if that's not what we want? What if I want a vector that's vertical? What if I want a column vector? So let's see. I want T is equal to 1, 1.5, 2, 2.5.
Instead of comma, we write with the semicolon.
You can't do that, so that would be if I was going to type it out, right, I would have to put semicolons to go to the next line, go to the next line, go to the next line. Unfortunately, that doesn't work with the colon or the linspace operator. So by default, those give me row vectors, and that's the only way I can do it. I can't flip some sort of switch and make MATLAB give me a column vector. However, there's a nice little trick in MATLAB. There's the transpose operator. So the transpose operator in MATLAB will flip the dimensions, so flip the rows or the columns. So it's really easy to do. So you can do it a couple different ways. So if we want our T vector there, let's do it with the linspace operator. So we'll say T is equal to linspace, and then what are my 3 arguments going to be? 3 inputs to linspace for T. 1, 2.5, and 4. And then all I need to do to transpose it to make it a column vector is use the apostrophe. And so I put the apostrophe at the end there, I press enter, and voila, I have a column vector instead of a row vector. So the transpose operator is a nice simple way to flip the dimensions, flip the rows and the columns of a vector that I have. There's also a transpose command. If you don't remember that it's the apostrophe, you can type out the word transpose and put the vector inside of it. So you could have something like that. Does the same thing, but I think the apostrophe is a little bit easier than typing out the word transpose every time. So easy to do. All right, so now we've used colon operator, we've used linspace to create vectors. What if we have a matrix? So, erase this stuff. What if I have a matrix like that? Do we have some patterns here, right? We've got some patterns. We've got numbers increasing by 1 in each column, right? So how are we going to do this? Again, colon operator and linspace will only create vectors. So we kind of have to basically create a couple vectors and then smush them together to make a matrix. That's the way that we're going to do it. It's officially called concatenation, but it's always kind of a word that nobody ever remembers. So smush is the technical term that I've come up with. So if we're going to create A there, what are we going to do? We want to do it one column at a time. So the first thing we're going to do is we're going to generate column 1, and we could use either the colon operator or linspace. And then what are we going to have to do with that to get it to be vertical? Transpose it, right? So we're going to create the first column using colon operator or linspace. Then we'll transpose it, then we'll do the same thing for 2 and the same thing for column 3. So if I want to create a matrix capital A, what do I have to do to tell MATLAB that I want this to be a matrix? Square brackets, right? So I got to open my square brackets, and now I want to do my first column. So let's do our first column with the colon operator. What am I going to write? 1 colon 4 colon 1, or another order? 114 or 141? What do we think? 114, right? Because we got to start, increment, then finish with the colon operator. So inside of this, I need to put, so I got my bracket for my matrix, and I need another bracket to tell MATLAB that that's going to be a column that I'm going to kind of control in one piece. So I'm going to put my colon inside there. So I'm going to say 1 colon for my start value, increment is 1, and a 4. Do I have to put that middle one there? No, right? Close my square bracket, and then I do my transpose, so my apostrophe at the end, and that's going to flip it so that it's a column vector. Now I want to move over to column number 2. How do I tell MATLAB I want to move to the second column? Do I need a semicolon, or do I need a comma, or do I need a space? Semicolon? What do semicolons do? Semicolons go to the next row. What if I want to skip over to the next column? Space or a comma, right? Either one. So I could do a comma. I could put another space in there. MATLAB will be happy with all of that. Then I'm going to move on to column number 2. I'm going to do, let's use linspace to generate column number 2. So I put it in square brackets. I say linspace. I open my parentheses. And then what am I going to put in here? 5, comma 8, comma 4 for 4 values. So where am I going to put my apostrophe? Am I going to put it before I close my square brackets or after I close my square brackets? Doesn't really matter, but usually I put it after. So for this case, it doesn't really matter. Now I got to go to my next column. So I put a space or a comma, and then we'll do the third one. You know, we could just be lazy and type out the third one, right? So if I want to do 9, semicolon 10, semicolon 11, semicolon 12, that's going to create my very last column that I have, right? If I press enter, hopefully I did everything right. MATLAB's happy, and I get my matrix the way that I want to, right? How'd we do? Okay? All right, let's see. So we talked a little bit last time about some of the common errors in MATLAB or debugging, right? And so one thing that comes up a lot, especially with commands in MATLAB, is you have to get the name exactly right. So for example, if I got, I was typing really quickly and I was making an A matrix with linspace and I left out the A, 1, 10, 12 or something like that. What's MATLAB going to do? It's going to yell at me first. It's going to say undefined function or variable linspace because I left the A out, right? And usually, if you're pretty close to what the actual name is, we just left a letter out or something like that, it tries to be helpful and it gives you this, did you mean blah, 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 and it tries to fix it for you, which is really helpful of MATLAB to do. But that's usually only if you get it kind of close. And then, you can press enter now and say, oh yeah, that was what I really meant to do. I really meant to have that with an A in it instead of without the A. So again, MATLAB tries to be helpful, but if you get those undefined function or variable things related to a MATLAB command, that's usually because you made some sort of typo in the name of the command. All right, any questions about linspace, colon operator, vectors, matrices? Not too bad yet, right? So what if we want to get certain information out of a matrix or a vector that we have? So we generated our A matrix and it looks like that. What if for some reason I only want to access or display one part of that matrix or vector? So what if I want to pull out this number 7? I want to do something to that number 7 there. So there's a way to do that in MATLAB. It's called indexing. And you're able to pull out certain values. You can pull out one value at a time. You can pull out a whole row or a whole column or part of a row or part of a column out of a matrix. And so the important thing to remember about indexing, so for indexing, everything follows the convention of row and then column in that order. So you have to tell MATLAB the row and then the column, which is kind of opposite from Excel. So most people are used to the Excel format, which is column and then row. But MATLAB, row, then column, and that's the rule. That's what you have to do. That's how MATLAB likes it. So what if I want to pull out that number 7 out of the A matrix? I want to pull out the number 7, which is going to be what? What row is number 7? 3. So unlike some other programming languages, in some other programming languages, indexing starts at 0. In MATLAB, indexing starts at 1. So row 1, 2, 3, you don't have to worry about the 0 row. That doesn't exist. So third row, second column. So if I type that into MATLAB, how would I do that? I would say big A for my A matrix. And then inside the parentheses, I would tell MATLAB the row, 3, and the column 2, right? Press enter, and voila, I get 7. So if I want to display a certain value from a matrix or a vector, I just follow that same format. What happens if I try A, 5, 3? What's going to happen? It's not going to be happy, right? We're going to get some sort of error. This error says index exceeds matrix dimensions. So we're trying to pull out row number 5, which doesn't exist in our matrix, right? And MATLAB's telling us this index exceeds the matrix dimensions. So you get a nice little error message with that one too. There's all sorts of ways to make MATLAB angry. Hopefully we don't have to. MATLAB can be nice to us for the most part. So that's if we wanted to access one element at a time. What if I want to access, say, the entire, fourth row of my vector? Or my matrix. I want all those values. What would I do? I go back to MATLAB, I put an A, and then I want the fourth row, so I say 4, and then I put a comma here. And now we got to figure out what we're going to do here. So we've got columns 1, 2, and 3, right? So we could tell MATLAB that. We could say, in a vector, we could say 1, 2, 3, like that. And MATLAB's going to print out 4, 8, and 12. It's kind of the long way of doing it. What would be a shortcut, potentially, that we could use instead of having 1, 2, and 3 in a vector? 1 colon 3, so we could use the colon operator. So we could say 1 colon 3. We get the same thing. A little bit less typing, still a little annoying. A nice thing about MATLAB is that you can use the colon operator to say, kind of tell MATLAB, I want all of something. So instead of typing 1 colon 3, I can just put the colon in there for the columns, and MATLAB automatically knows that I want all the columns. That's just telling MATLAB, give me all the columns in the 4th row. So the colon operator can also mean all the things in that particular deal. You could have either all the rows or all the columns, depending on which part of that you put it in. Okay? Let's see. You could also do part of a row or a column. So we had, I don't know, let's see. We had our t vector that looked like this. So this was t here we generated earlier. What if I only want to print out 2 and 2.5? The last 2 values down there. What do you think I'd write and type into MATLAB here? So t, then what?
3 and 4. 3,
What else do I need after t, before I start writing 3 and 4? Parentheses, right? So t, so 3 and 4 are going to be what? So that's the column or the row?
Yeah, this is the row.
The rows, right? So I could say 3 colon 4, and then I've got a couple different options. If I just do 3 and 4, MATLAB's happy with that. It's kind of a shortcut. Usually I like to be explicit, and I like to give it MATLAB both the row and the column, even though we only have 1 column. So I would put comma 1 for the first column, right? So just to be 100% certain that I know what I'm going to get when I put that in there, I always like to specify both the row and the column. If you have a row vector or a column vector, you don't necessarily have to provide both dimensions, but I always like to do it just to be on the safe side. Okay, any questions about that? All right. You can also use that same notation to change certain parts of a vector, or a matrix. So if I want to take my last, let's see, our last column of our matrix over here. Take this last column, and I want to set to, I don't know, all values equal to 5. I can do that using kind of the same format. So I'd say A, and then I want to do my last column. So how would I write that in MATLAB? Colon, comma 3, because we have all the rows in column 3. I want to set that equal to 5. So I say equal to 5. Press enter, and MATLAB knows that I want all those values equal to 5. That's how I tell it to do that. So that's another kind of trick that you can use. What are some other tricks in MATLAB? So if I want, for example, an entire matrix or a vector of all values that are equal to 0, I could say, I don't know, b is equal to zeros. MATLAB has a function called zeros with an s on it. Z-E-R-O-S, no extra e in there. And then I have to tell MATLAB how many rows and how many columns of zeros that I want. So if I want 3 rows and 6 columns of zeros, I tell MATLAB that, and I get a big matrix of zeros. 3 rows, 6 columns, just like I asked for. So that's another trick that you can have to create matrices. You can also do column vectors. So just like the zeros function, we also have a ones function in MATLAB, O-N-E-S, that will generate a bunch of ones. So I can have C is equal to ones. And if I want, I don't know, 10 rows and 1 column, I can do that as well. So those are some other handy tricks. Unfortunately, there's not 2s and 3s and 4s and 5s, other functions. There's only ones. But what if I wanted a whole vector of, say, values equal to 10? Could I use the zeros or the ones function to do that? Handy math. I have a vector of ones. How can I make that vector of tens? Multiply by 10, right? So if I want my C actually equal to 10, multiply by 10, and now I get a whole bunch of, multiply the ones function by 10, and I get a whole bunch of 10s. So you can use the ones and the zeros to do a lot of things, kind of handy little tricks. So that's all your kind of MATLAB vector matrix creation tricks that I've got. As we said in class the first day, MATLAB can be, kind of a fancy calculator. It's good for doing addition, subtraction, multiplication, division, all that kind of stuff. But where it becomes really helpful is when you have matrices and you want to do those operations on matrices. So if we have our, let's see, I'm going to create some new vectors. So I'm going to create some new vectors. I want to clear out the stuff I've already got in my workspace. How do I do that? CLC, what does CLC do? Does it clears the display, right? So I CLC and my command window goes away, but I still got all that stuff in my workspace. I want to get rid of that stuff. Clear, right? So I clear and I get rid of all the stuff in my workspace. So now I want to create a vector, we're going to call it little a, and I want it to have values between 1 and 5 that increment by 1. What's the easiest way to make that vector? Linspace. So if I want linspace 1, 5, and 5, right? I wanted values that incremented by 1. Could I have done it with the colon operator? Yes, right? So either one, those are kind of interchangeable. There's no clear way why you'd want to use one over the other. So I've got A. Now I want B, and I want B to be a column vector with values that start at 2 and end at 10. 5 values. So B is equal to, what do we want to do? Colon or linspace? Colon, so let's do 2 to 2 to 10. And now I want that to be a column vector. So what am I going to have to do? Apostrophe, right? But what did I forget? So if I do the apostrophe here, I still got a row vector. I forgot my square brackets, right? So I can always recall that previous command. Remember, we can do that with the up arrow. So we up arrow, I don't have to retype the whole thing. And then insert our square brackets, press enter, and I get my column vector the way I wanted it to, right? So now, if I want to multiply A by B, can I do that? So can I say, so let's say C is equal to A times B. Does anyone remember what our rules about matrix multiplication are? So we have A. So A has what dimensions? How many rows and how many columns do we have in A?
We have
one row
one row,
and 5 columns, right? So 1 row, 5 columns. I want to multiply it by B. B has what dimensions? 5 rows, 1 column. So 5 by 1. Rows, columns. Is that okay to do matrix multiplication with?
no.
Yes? Why? Right, so we have to have, when we do matrix multiplication, we have to have our inner dimensions have to match. So these dimensions have to match. Inner dimensions must match. So that's the thing that has to agree. So we have to check that the columns of the first matrix are equal to the rows of the second matrix or vector. And then what size is C going to be? Do you remember the trick for determining that? 1 by 1, right? We take our outer dimensions. So we have 1 row, 1 column, and that tells us that we should get C to have 1 row, 1 column. If I try that, voila, that's what I get, right? So MATLAB can do matrix multiplication, no problem. If I were to try the opposite, So if I were to try, let's say D is equal to B times A, is that going to be okay? Yeah? So we press enter, and we now get a 5 by 5 result because we've swapped now the order, and so we would expect our result to be 5 by 5. So that's basic matrix multiplication in MATLAB. What if I don't want to do matrix multiplication? So MATLAB also lets us do what's called element by element multiplication, or some element by element mathematical operations. And what do I mean by that? So I have A and I have B. And what I want to do if I do something called element by element multiplication, or some sort of element by element mathematical operation, is I'm going to take each element of A and do the same mathematical operation to its corresponding element in B. So if we look at A, I want to take 1 and multiply it by 2, which is the first thing in B. I want to take 2 and multiply it by 4, 3 multiplied by 6, 4 by 8, and 5 by 10. So I want to do that on a kind of element by element basis. And then I just want to get 5 numbers out of it, because I had 5 A's, 5 B's. I want to multiply those together and get 5 values as my result. So how do I do that? MATLAB has a special operator called the dot operator. So we could say F is equal to A, and instead of having just a regular multiplication sign, we have to stick a dot in there. So just a period, multiplication symbol, and our B. And why is it mad at us? So we have one row vector and we have one column vector, and we're trying to match those up. They don't match up. So we have to transpose one of our vectors, and then we'd actually get our result that we expect. So with the dot operator, you can do this element by element mathematical operations, but there's a couple rules. So the rules are that the matrices, or the vectors, have to have the same size, they have to have the same number of things, and they have to be in the same orientation in order to do that. Oops. So we'll start our list. Erase this stuff. There's several rules related to the dot operator. So we'll start a list. So with the dot operator, this is element by element math, basically. You can do it with multiplication, so you can have dot times. You can also have element by element division, so dot backslash or the division symbol, or I guess that's probably a forward slash. And then you can also do element by element raising something to a power. So we'll do some examples of those. You don't have to do, or you shouldn't ever need to do, element by element addition or subtraction. Those are already done on an element by element basis. So you don't ever have a dot plus or a dot minus. Those are not things that exist. So never dot plus or dot minus. That's a big no-no. So don't do those. So when do we want to do this? So what are the rules? So we have to, so the vectors or matrices must be the same size and dimensions. So if one has 2 rows and 3 columns, the other one has to have 2 rows and 3 columns. And then there's a couple other rules about when we can use them and when we cannot use them. So for multiplication, we only need that if we have 2 vectors. So I have my A vector and I have my B vector. If I multiply those together, then I need the dot operator if I want to do that on an element by element basis. If I have, I don't know, if I want to take 2 and multiply that by all the values in A, I don't need a dot. So if I got a scalar value 2, I want to multiply it by a vector or a matrix, no dot is required. So we'll add that to our rules. For multiplication, So dot star vector dot times vector is where I need it, or matrix dot times matrix, but I don't need it if I have a scalar times a vector or a scalar times a matrix. So we don't need one there. So dot, dot, no dot. So what about division? So we said we could do element by element division. So if I want to take our A and divide it by B, so if I were to try A divided by B without dot, MATLAB's going to yell at me. It's going to say, you know, the dimensions don't agree. And in fact, matrix division really isn't a valid mathematical operator anyway. So we can't really do that, even though MATLAB tries to make you think you possibly could. But what if I want to take every element in A and divide it by every element in B? I could stick a dot in there. What else am I going to have to do? The transpose, right? I need those to be the same dimensions. And you'll see, you know, I get 1/2 across the board because we had all the vectors like that. So if we have that, so we have two vectors or two matrices, we want to divide all the elements by each other, we need a dot. So that's kind of the same rule as we have for multiplication. So for division, we have a vector divided by a vector. We need the dot. We have a matrix divided by a matrix. We need the dot. Now what about scalars and vectors with division? So if I have I is equal to 1 divided by A, we need a dot. So if we have a vector or a matrix on the denominator of a fraction, we need the dot. So a scalar divided by a matrix, we need the dot, or a vector. What about a matrix divided by a scalar? So if I take B and divide it by 2, what do we think? Dot or no dot? You want to take a guess? No dot required. So no dot is required for matrix divided by scalar. So if the matrix or the vector is on the numerator of your fraction, no dot required. If it's on the denominator, you have to have a dot. So those are your division rules. And then the last mathematical operator related to the dot is the power, or raising something to a power. If I want to take my A vector and raise it to the second power, so A raised to the second power, I'm going to need a dot. Because if I'm taking A and raising to the second power, if A is a matrix or a vector, really what's happening is we're taking A, we're trying to multiply it by A. That's what squaring it is. And so those dimensions would have to agree, which they don't, so we need to do it on an element by element basis and square it. So we have 4 powers. We have a vector raised to a scalar, or a matrix raised to a scalar. We have to have the dot. What if I wanted to raise, let's see, a scalar, 1, to a matrix or vector power to the A power, oops, A power. Again, I'm going to need a dot. So I stick in my dot, 1 raised to the something powers, all ones. So a scalar raised to a vector of powers, or a matrix of powers. I have to have my dot. And what would be my last combination? If I have two vectors, so n is equal to a raised to the b power, where a and b are both vectors. Let's see, what do I need? My transpose. Okay. No? Uh-oh. What did I do? Ta-da. There we go.
Why do we need the transpose?
So the A and the B, remember they have to have the A and the B. A was a row vector, B was a column vector. When you do element by element, they have to be the same size and the same dimension, right? So we have to flip it so that it's the same dimensions. So if I have a vector raised to a vector, I also need the dot, right? What else? I think that's all those rules. So what happens is that once I've taught you the dot, you want to put dots everywhere. Dots all over the place, all sorts of dots. Dots are not necessary for a lot of situations. These are the ones where they apply. These are the rules. Use them appropriately. You can get yourself in trouble if you use too many dots. So don't go dot crazy. In fact, sometimes I take off points for extra dots. So make sure you know the rules for the dots, where to use them and all that kind of stuff. Let's see. So that's all my rules and all my introductions. So what we're going to do is we're going to get started on, in the last, what are we at, 12 minutes, our first in-class exercise. So we're not going to get done with this. So there's 2 pages, front and back on this sheet. You're not going to get done with this today. So we're going to start it today, and then we'll finish it at the beginning of class on Wednesday. And then what we're going to do is have you guys turn these in. So I'll turn these in on Isidore. This is part of your in-class participation and exercises portion of your grade. And so what these exercises are is just practice for you guys. So if you do them, you will get a good grade. I'll say that again. If you do them, you will do a good grade. It doesn't matter to me if they're correct or they're not correct. When you turn them in, I just want you to get practice, right? And so what am I going to do? So after we turn these in on Wednesday, I'm going to go through them and I'm going to give you comments back. I'll tell you if you've done something wrong or right or whatever, but you're not going to lose points for something like that. So I want you guys to get practice without worrying about, getting a grade that really is reflective of, if you totally missed a boat on something, right? Question, Adam? Oh, good. That's right. We won't start this today. We will start this on Wednesday. Sorry, I forgot. Whole new schedule thing. But we will start this on Wednesday. So one more thing before you pack up. So how do we close our diary file? So if you close MATLAB, it'll automatically close. If you type in diary off, it'll also close. And once you have the diary off, you can double click on your diary file and you can open it up and actually look at it in MATLAB and that kind of stuff. So like I said, we'll talk more about that next time. But thanks. Sorry. See you guys on Wednesday.